I'm really excited to be here. So yeah, I'm gonna get going on this applying the PASO standard to community centers. So this is the key content that I'll be covering today. A little bit of background about myself and background about the project, and then I'll dive right into building enclosure systems, mechanical systems, and some of the key challenges specific to this project. So just a little bit about me. I graduated from BCIT with a bachelor's of mechanical in 2010, and then I practiced as a naval architect for about 5-6 years. And as a naval architect, we specialized in loading out and launching oil rigs in Dubai. And so here's some photos. These oil rigs are typically built in shipyards on land, and we provided a method for launching them. So a lot of these oil rigs are not built on dry docks, where you can just sort of flood this basin basically and float off the oil rig. So they end up getting built on land, and then they get moved and transported onto a submersible barge. And then this submersible barge gets dragged out into open waters where it's deep enough. And then we provide a method to sort of launch these oil rigs. And so I did that for about 5-6 years. And I decided that's just not my not something that I wanted to continue as a career path. And I thought deeply about, what are the sort of real big challenges that we face as a species today, and climate change was definitely one of them that rose quickly to the top of that list. And so I decided to go back to school, and I did my master's of clean energy engineering at UBC, and then I quickly fell in love with sort of building energy efficiency, and eventually I found myself sort of learning about Passive House, and the Passive House principles just made sense to me as a sort of evidence-based, science-based approach to building design. And I sort of thought, well, why isn't every building like this kind of thing? And then shortly after that, I joined RDH as a Passive House consultant. I've been with them ever since, and as part of the energy and climate team. And as part of the energy and climate team, I started practicing as a Passive House consultant. And so I started off with just really simple buildings, single family, sort of these kind of luxury, high-end single family projects. And then as the adoption grew in Vancouver, I started to work on sort of larger buildings. So this is a mixed-use residential building in Whistler, a 20-unit sort of rental building. And then it started to scale up. So this is UBC Oskina, located in Kelowna, and it's a 6-story student dormitory, 220 beds. And then it continued to scale up. So now this project is in construction. It's located in Vancouver. It's a 9-story social housing project with 84 units, and it also has a childcare on the ground floor. And then this is also another project that is currently in construction, a 154 unit, 17-story social housing project with an office in sort of level 2, and then also commercial retail units on the ground floor. And then this is another project that I'm also working on. It's 283 unit, 28-story supportive housing, with a mixture of supportive housing sort of in the middle of the building, and then also market units on the upper floors. It has a childcare component to it, and like sort of at the top of the podium, and then also a fire hall. And the fire hall is pursuing Passive House certification. And also a community center. So a little bit about this project. The Marpole Oak Ridge Community Center is located in Vancouver, BC, and it was built in 1949, and it's the original project intent is that it was sort of dated and aging building systems, and also undersized for the population that it was serving. And so there was an outreach and surveys. So the city conducted surveys to determine what the needs of the communities are, and they identify sort of 4 key goals with this new project. It needed to be a place for social gathering, so a meeting space and also a community hub. It needed to encourage active lifestyle and physical literacy. It needed to house a lot of cultural programming, and it also needed to have all age supports from seniors to youth to young families. So that automatically meant like a daycare. And also it needed to provide resilience and sustainability goals. So community centers are needs to be able to support the community in case of disasters and emergencies. So in order to do that, it needed to be built to the highest building code standards, which introduced the Passive House certification, LEED Gold, and also embodied carbon reduction by 40% compared to the 2018 baseline. So the programming. So this is a 2-story building over top of underground parkade. So this is the community center, and then it also has this change rooms facility that is semi-conditioned. So it's kind of outside the certification boundary, and it also has an outdoor pool. As you can see, it's not a retrofit project, it's a completely new building. So the existing building is to the north here, and then the new building is to the south. So the programming. So there's some key services to this building. In level 1, we have a gym there in orange, a fitness area in blue, senior and sort of multi-purpose rooms, spaces for cultural gathering here in green, and then a childcare on the 2nd floor. So a little bit about the building enclosure. It's a super insulated building enclosure. So we have a split insulated wall of R54, which is equivalent to like 8 inches of exterior insulation with thermally broken cladding supports. Inverted deck and roof assemblies of around R65, and a suspended sandwich slab of R64, which ties into an overall enclosure performance of about R25, including all thermal bridging, all windows, everything. So in terms of windows, we have, for the punch windows, we have Cascadia Universal Series. And then for the entrance areas, curtain wall, Ricotherm window systems. So these are all Passive certified. There are few areas where where we're using non-certified systems, and those are typically like egress doors and things like that, where there needs to be a fire rated door. So in terms of mechanical systems, we have air source heat pumps. We're using air source heat pumps for heating and cooling, and hydronic 2-pipe fan coils and radiant panels. So Passive House buildings are characterized by super insulated enclosures and exceptional air tightness, which lends itself to like a high thermal inertia. So it plays a role in selecting some of these terminal systems. So fan coil units allows for a faster response time to temperature fluctuations within a space. And radiant ceiling panels sort of allows for the ability to centralize maintenance, as the panels don't require the same regular maintenance as the fan coil units. There's no filter, there's no fan. And so the use of radiant panels are really great for spaces like the Great Hall, multi-purpose rooms, and youth lounges. For domestic hot water, we have CO2-based air source heat pumps. They offer high COPs with high lift capabilities, and CO2 is a natural refrigerant, so it's more attractive compared to the traditional refrigerant systems like R134A and R410. For ventilation systems, we have Passive certified Swegan units zoned depending on the hours of operation and also set points for the various spaces. So we have one system that serves the fitness and gym area, and multiple systems that serves the the community center and sort of the childcare is on its own system. So it enables systems to be shut off when they're not in use. And also the ventilation system is completely decoupled from the heating and cooling system. So meaning that the fan coils can run independently from the ventilation system, which minimizes fan energy. So some of the key challenges, so there's really two key challenges. One is the commercial kitchens that are on this project, and two is the fact that it's a non-standard building typography. So for commercial kitchens, the city of Vancouver defines 4 classes of cooking operation. The class 1 is where you think of as a traditional commercial kitchen where there's smoke, there's grease-laden vapors. Class 2 is cooking equipment that produces steam or heat, but not grease-laden vapor. So think of just kind of like boiling water or making coffee. Class 3 would be cooking equipment where there's limited smoke or grease-laden vapors. So think of cooking that is traditionally done in a single-family home. So you're not serving hundreds of people, maybe just like a small family. And then class 4 kitchen, class 4 cooking operation is cooking where there's no heat, there's no steam, there's no grease-laden vapors. So think of like microwaving lunches or creating, like making sandwiches, that kind of thing. So, so there's a total of 4 kitchens in this building. The first kitchen is the senior center. So it's classified as a class 1 kitchen where we're serving hundreds of people for events. So it's adjacent to 2 multi-purpose rooms. It's highlighted in red here where the kitchen is located. So it drives kind of both the selection of the ventilation system specific to that cooking operation, also locating that kitchen to near an exterior wall to minimize duct lengths, and also making sure that the kitchen is located at a location that makes sense for serving the adjacent spaces. Kitchen number 2 is an after-school care, and it's meant for light food preparation and snack time. So, so it's classified as a class 2 kitchen, still used fairly regularly. In class 3 kitchen is the staff kitchen. The intent with this kitchen is just mainly to reheat lunches and make sort of light food preparation. So there's class 4. So really there's no real grease or steam or vapor. Class 4, or so kitchen 4, is for the childcare spaces on the 2nd floor, and that is classified as a class 2 kitchen, still used fairly regularly. And identifying these classes of kitchens for each of these kitchens allows us to understand what the ventilation requirements are. So you sort of using the appropriate kitchen ventilation solution to the usage. So so for the senior kitchen where we anticipate there's going to be a lot of cooking to serve multiple events, a direct exhaust system was selected, and then where we had less cooking, we would use a sort of a recirculating range hood coupled with an ERV extract. And then for the staff kitchen, where there's not really anticipated any cooking, maybe just microwaving lunches, there's no recirculating range hood, it's just an ERV extract. So the second challenge with this building typography is that it's a non-standard building typography, meaning that for PASO certification, there's no set PR target, and that PR target needs to be determined project by project, which introduced a lot of complexity in terms of certification and also in terms of designing the building. So for most residential buildings, these are presets, right? PR is a predetermined thing, a predetermined target. So it's 60 for single family homes, and it's projects determined in PHPP for larger mixed-use residential buildings. So for this project, it's a custom determined target along, it needs to be determined with the building certifier and also the PHI. And so everything that goes into the model is essentially user determined. So user determined internal heat gains, user determined occupancy, user determined domestic hot water consumption, user determined plug loads, user determined lighting usages. And on the right here, there's a I show it like a heat balance of the project, and you can see how big of a chunk internal heat gain is, right, relative to the whole building. So if we're off by 10%, I mean that's different. That's the difference between 8 inches of exterior insulation on the walls or 4 inches of exterior insulation. So it matters a lot that to get this right from the get-go to drive the design properly or from the beginning. And the other thing is the PR is 65% of the PER is from non-standard uses. So this is a PR breakdown for the project. You can see heating and cooling is actually quite a small portion of it. And 65% of that is driven by what you have in the green here, which is domestic hot water usage, including all the circulation losses, tank losses, that kind of thing. And then all your plug loads. So we have elevators, common area, lighting, kitchen appliances, and then sort of plug loads. So occupancy. To determine the number of occupants to model in PHUP, we need to systematically determine the loads. So we need to start from design occupancy for each space and apply the appropriate occupancy schedule to the space. So the occupancy schedule, we leaned in heavily to NECB schedules, the default schedules for different space types, but we adjusted it based on the hours of operation for the building. For plug loads, we have space by space equipment schedules, and we need to use the appropriate usage for each piece of equipment. And it could be pretty overwhelming for a building of this size at first, but I think the important aspect of this is to just get started and use assumptions wherever possible, and refine inputs as the design progresses. Similarly to lighting, we have a space-by-space lighting schedule. In initial SD, we started with ASHRAE 90.1, used lighting power densities, and then we worked with the electrical designer to see if we can improve on the lighting power densities and also apply the appropriate lighting controls systems to further reduce lighting power. For domestic hot water, we used we need to use the secondary calculation to determine domestic hot water requirements. So we went through each application of use and systematically reviewed each application and make reasonable estimates based on the occupancy calculation. And so the devil is in the details. So we need to engage with the building certifier early, review these key assumptions, and we need to clearly document all of these intricacies to the model. So this includes set points, how we've zoned the building, occupancy calculation, how do we arrive at an average annual occupancy that we need to use in PHUP? How do we arrive at the internal heat gain calculations? What was accounted for in terms of internal heat gain and what was not accounted for, and what was the justification for it? Plug loads and lighting calculation assumptions, and domestic hot water usage assumptions. So some of the key takeaways here. So model the building early and engage with the building certifier. Non-standard building typographies require project-specific PR targets. Understand the key set points for different zones, occupancy schedules. And then we need to systematically determine occupant loads, domestic hot water loads, plug loads, and lighting. determine key kitchen usages, and apply the appropriate ventilation solution to the kitchen usage. And then iteratively refine the assumptions and inputs as the design progresses. And that's it.
Thank you so much. We had several comments on great graphics, which it's really helpful to understand these things, just looking at all these details and graphs and things that you were considering and weighing against each other. So thank you for that, as well as, you know, just filling us in on how you and your team approached this new typology and some lessons learned there. We definitely have a few questions waiting for you in the queue about the approach and details, and we will get to those as soon as we get back from some messages from our sponsors.
Thank you, Zoe. Filling in for Zach today, so bear with me. Starting off with our founding sponsors, we'd like to thank 475 High Performance Building Supply, Ingui Architecture, Glavel Foam Glass Gravel, Minotaur All-in-One HVAC D Units, Partel, Rockwell North America, Stocorp, and Zola Windows and Doors. Our champion sponsors include Bewiso, Gradient, Icon Windows and Doors, Intelligent Membranes, PH Air Seal, Proseco, and Source 2050. And then on to our patron sponsors, Brennan, Euroline Windows, Holzraum System, Innotech Windows and Doors, Lamelux, RDH Building Science, Sanderson Design, and of course, our stakeholder partner, NYSERDA. I'll hand it back over to Q&A.
Thanks, Kim. As always, Zoe and I have a ton of questions and we can jump into those. And I think I'll start with kind of what you mentioned at the end of engaging a certifier early and talking about the process of making like unique kind of user-defined decisions around plug loads, domestic hot water loads, and these things. Can you talk about that process, how it was going back and forth with the certifier, as well as like what had to go up to the level of PHI?
Yeah, I mean, I think we started reviewing we submitted the project for design stage review at like 50% DD. So it started pretty early. We wanted to get the involvement with the building certifier to identify sort of at a high level how we're modeling it. I mean, PHP is a single zone model, as we all know. And there's a lot of workarounds and hoops to jump through to make it do what you want it to do. And so in the original intent, well, we modeled this building as one PHP for a lot of reasons at early SD to get a sense of where the range of targets are. But we had the original intent to separate it into separate zones because of hours of operation, but also set point differences. But after discussing with the certifier, we believe that keeping it all in one and introducing these workarounds is a much better approach. Just for maintaining the PHP, right? Like if during construction we need to maintain 3 PHPs, that's 3 times the work for everybody. And it lends itself to more prone to human error as we're updating the model, as we're evaluating different value engineering options.
Makes a lot of sense. And yeah, the room for error on like weighted averages and trying to piece that all back together can prove difficult. And ultimately you want to see how the building is working as a single system, even though it's serving so many different programs and functions. Zoe, you are up next.
Well, similar to you, I had multiple questions, but I will choose one to start out with so we can get to other people's questions. I was wondering, you mentioned the fire-rated doors as kind of a thing that was missing as like a certified passive house component. Are there any other products or components that you've identified as still sort of missing from industry that would make your job easier here?
Revolving doors. I mean, the community center has two giant revolving doors on either end of the building. It'd be nice.
How did you deal with that in terms of floor door testing and just approaching all of that?
Well, we haven't selected a door yet, so we're still working through that. But it has a vestibule. So currently the airtight boundary sort of wraps around the
Okay.
revolving door. So the revolving door technically is an interior door.
Got it. That makes sense. Up next we have Valerie J. Amor. Would you like to come off mute and ask your question?
Okay, yes, can you hear me? Yeah, so I was just wondering about the set points that you had. They seemed like they were more passive house ones, but not typical. So maybe the heating is a little bit lower and the cooling is a little bit higher. So I was just wondering if you did like an occupant comfort survey. Was there any response? Like, did they feel a little chillier in the winter or did they feel a little too warm? Because I've mentioned like 77 degrees and people do, oh no, it would be so hot. So I'm just curious what kind of reaction there was inside the building and people and how they felt.
The building is in construction right now.
Oh,
So it probably won't be finished until later this year.
okay. As you've used these set points before, though, than other buildings that were occupied that you might know how the response to it was?
I'm not sure. But
Okay,
these set points are pretty typical.
okay, thank you.
We'll have to report back in a year or so, get a full, 4 seasons, full year of occupant survey data. And I think Aaron, who's also in Vancouver, was up next, but he was asking us to read his question. So I'll go ahead and ask it. It's regarding the kitchens that you were speaking about. And he asked, how is makeup air being delivered to the kitchen ventilation system in the senior kitchen? Is it through the Swagon unit?
No, makeup air is provided directly to that space. So the direct exhaust. So the intent is to keep the HRVs. All the HRVs must be balanced, right? And also to keep that space balanced, the kitchen room.
And Aaron, I see you're on. Was that? Yeah.
Sounds
Cool.
good. It's obviously with the building envelope as tight as it is, that's super important. So dedicated is. Thank you.
Very good. All right. Next we have Scott Kennedy. Would you like to ask your question?
Hey, Sherman. I was just curious, when I looked at your water circulation losses and heating effects in your model, was that just for domestic water or was that including heating and cooling water?
That's just domestic.
So did you look at having systems that are more local, right? Just even if it's a small use system, even if it's electric resistance, on demand heating for, small uses like washing hands, and having systems rather than having a big central system, having the smaller systems that are more unique to each space, more set up for each space.
Yeah, I don't know if that was considered. Introba was the mechanical on this one, but I'm not sure if they considered that.
All right. And then just in terms of cooling, you were using radiant. Are you using radiant energy for cooling as well? Like, are you actually cooling the panels
Yeah,
in the gyms and stuff?
Yeah.
Okay. And then that obviously it leads to the question of condensation that we all worry about when we try to do that. So yeah, maybe Stuart will weigh in. I think I saw him on there somewhere.
Got a question. Were there any efficiency strategies applied to the outdoor pool?
No,
Or
the
maybe I missed them.
outdoor pool is outside of the certification boundary.
Oh, okay. Interesting.
And so is the shower or change rooms. So the interesting thing with the shower change rooms is that the hot water system for the building serves both the community center and the and the change rooms, because there's like washrooms and shower rooms and things like that in there. And so all of those circulation lines are added to this model because it's part of the system. And that had a sizable impact.
So even though it was serving a space that was outside of the boundary,
Yeah.
since it was connected to a space that was inside the boundary, it's included.
Exactly. Yeah.
That's interesting that, even though I guess I'm kind of surprised actually that the pool could be outside of the boundary just because it's outside, because it's still like part of the function of the community center, right? Was there any dialogue about that, or like what was the reasoning there?
Yeah, that I'm not sure.
That's fine. That's interesting though. Helpful
Mhm.
to understand how to treat outdoor pools there. Okay, looks like our next question comes from Diego Ortiz. Are you able to unmute and ask your question? No, you are not. Okay, we will ask it for you. All right, Sherman, can you speak more to complex details where assemblies with high levels of insulation came together? Is this something that certifiers provide comments on? In parentheses, roof wall, sandwich slab, exterior wall, etc.
Yeah, I mean, for sure, that's something that building certifier will review, sort of detail by detail, what the lengths of each details are, and is an appropriate side value assigned to those details. I mean, there's definitely lots of tricky details on these types of projects, and I mean the most common one is probably the exterior wall perimeter at grade. Those are typically pretty tough to be thermally broken, and just because it's mostly concrete, and there's usually some sort of curb that the wall needs to sit on. So those types of details are definitely tricky.
That was my immediate question when you showed the snips of the assemblies, is how did you connect continuously? And it sounds like you weren't able to have a continuous connection between the sandwich slab and the wall. So you just kind of took the thermal bridge hit in that.
Yeah, there's a little bit of thermal bridge in there for sure.
Yeah. And that also ties into the comment that I think Sean made about, you look at those wall assemblies and roof and slab, and they're in the like +50, +60 R values, but then you mentioned an overall of like R25. So, and that's accounting for the thermal bridges and the fenestration, or just the thermal bridges?
Thermal bridge of common interface details, window installs, all the doors, all the sort of like fire rated opaque doors that are thermally not great, and also all the windows.
Yeah, big impact. No matter how beefy you make your through wall like opaque assemblies. I wanted to just give a chance to circle back to the conversation that Scott was having on domestic hot water as well as set points, because we have Stuart on from Introva. So Stuart, if you want to weigh in.
Yeah, I just say on the radiant is only in the multi-purpose rooms. It's not in the gym areas where there's potential for sort of high humidity from users. We don't have radiant panels in those spaces. The hot water, because of potential for large shower loads. The outdoor pool is seasonal, of course. Because there's potential for large shower loads, everybody goes for a shower after being in a chlorinated pool, right? So we got a fairly substantial system in there to deal with that. And it's also the shower loads in the gym. And, people don't shower as much in gyms as they maybe used to in the past, but, you've still got to sort of allow for that potential. And so by the time you've done that, if you start, and hot water is often quite distributed, and scattered around the building. So it's, you could put lots of point of use heaters in, but you really just don't know what that load's going to be. And so, because you've already circulated it for the shower loads to deal with sort of, quite peaky loads, if you get a, basketball team in there that all decide to shower afterwards, and you've got to be able to sort of deal with that. And so you've already got the water in the vicinity of those areas. So point of use doesn't often make that much sense, I would say. But it's one of the biggest challenges in domestic hot water systems is the domestic hot water use, and often it's governed by, you know, architectural layouts and where those fixtures are placed. And I think there's a lot to be said for sort of looking at that through the architectural design. You know, trying to back-to-back washrooms and different sort of hot water fixtures, then trying to sort of fix it with scattering, you know, high demand electric heaters all over the building. What was the other question? Was temperatures? I would say the temperatures, you know, on the Clayton Heights project, which is very similar to this one in its application, we did, when we went back and looked, they were running the building slightly cooler in the summertime, and so I would expect to see that here. But at the end of the day, you put in the temperatures that you put in, you know, from a compliance perspective. And what we didn't find that cooling energy was a big use. The biggest use that we found at Clayton Heights was lighting. Actually, you know, cooling and heating look tiny by comparison to sort of the lighting energy. So I think that's one of the most important places to focus on buildings like this, making sure those lights are off in the summertime. Was there another question? Did I cover everything there?
I think that was excellent. You covered both Scott and Valerie's questions. So thanks so much, Stuart.
Okay.
I guess I've got a related one. Then so, and this might be difficult to answer, but you know, how do you balance kind of the need to accommodate erring on the safe side with sizing equipment and you know, allowing people to have hot water for all their showers that you think they may or may not take, while also modeling this and thinking about reasonable assumptions. Were there any, you know, different assumptions that you made in terms of sizing and designing equipment versus what's sort of assumed for certification, maybe?
Yeah, I guess in terms of, I mean, I can't answer the sizing part. Stuart can probably answer that, but in terms of modeling, it's hard to say like what, like if you're modeling more occupants, you're sort of gaining that internal heat gain, so that your heating demand goes down, but then you're also introducing a lot more plug load usage, and so it's not necessarily conservative to have lots of occupants or less occupants. It really matters that it's driven by the design of the building and making sure that the numbers are actually correct.
Yeah, that makes sense.
In terms of sizing, you know, with heat pump domestic hot water heaters, typically we're putting in, you know, smaller heat pumps and larger storage. You know, I would say compared to fossil fuel systems, we looked at this in a number of residential projects, and the order of magnitude is sort of like a 4-to-1 switch between sort of, you know, heating capacity and storage capacity from a fossil fuel system, which have lots of heating capacity and smaller storage. So we do end up with some bigger storage tanks, and so that's where you sort of get that sort of you know, safety factor, I would say, right? You know, but it's one of the things that we do have to look at is, you know, putting in better tanks with better insulation. These days, the CO2 tanks are heating the water up much higher, so up to 70 degrees centigrade, which is, you know, 155 Fahrenheit, something like that, right? So much hotter. So consequently, you know, you've got more storage for the given volume, right? More usable storage, if you like. Because of that higher temperature, but you've also got more heat loss. So you've just got to be careful with where those tanks are placed. The tanks, you know, are sitting down in the in sort of semi-heated mechanical rooms outside of the thermal envelope, if you like, right? Because they're down at the parkade basement sort of level. So, you know, one of the challenges you get is that overheating of heat from that storage into the space. We don't have that in this case because it's outside of the thermal envelope.
Interesting. Yeah, that makes a lot of sense because it's so difficult to plan for an unknown occupancy and those swings. So the buffers in the storage, that makes a lot of sense. And then also locating that storage so you're not neither taking the hit on so much additional heat gain internally, But I'd be curious to see over time with the use and the seasonal use of, you know, of the seasonality of the spaces, what the heat loss of those tanks are down in the parking area.
Sherman, I wanted to actually circle back to, it was one of your first slides. Maybe you can share again. It was that that graph of risk assessment. It was like a chart showing various risk categories, I guess. Are you able to share again?
Yeah, just one second.
Okay, cool. Thank you. Yeah, that's the one. Okay, so this is for this project in particular?
No, this is not specific to this project.
Oh, okay. Do you consider this for all projects, and how do you end up, you know, deciding what to focus on here?
Yeah, I mean, I think we try to think about all of these things when we're designing the building. So things that pertain specifically to Vancouver would be things like wildfire, heat waves, yeah, extreme storm, flooding, that kind of thing. Those are definitely key things that we thought about, and also like, you know, when like things like HRV selection, having the ability to change into like a MERV 15 filter during smoke events is something that was definitely considered.
Yeah, for sure. Makes sense. Okay, so this is like a chart that we can all use kind of to look at, you know, what are some severe events or some risks, and how much to like, I guess depending on the location and the type of building, you know, it kind of gives you a visual cue as to like how to just go about thinking about that risk. That's pretty
Exactly.
cool.
This reminds me a lot of, if anyone works in the other certification spaces like Enterprise Green Communities and LEED, EGC in particular requires doing a like climate risk assessment and kind of plotting the same graph using, you know, your site and local maps, and, you know, looking out to 500-year flood maps, and what are like the heat risks and fire risks and all of that, and deciding, yeah, just like this graph shows, what was the risk level and the confidence level based on the source that you got that information, and then what are the mitigation strategies, and how are you like prioritizing design decisions around those things. So it's a great reminder. We don't just deal in building energy. So with that, I think that we didn't get any other questions.
We have one more, actually.
Oh, we do have one more question.
Yeah, we have one more from Eric R. It was a sneaky reply to another chat, but Eric, do you want to unmute and ask that question? If not, we can ask it for you. It was a good one. All right.
Sorry, am I working?
Yep.
Yeah.
Yes.
No, I was just, it seemed like I normally wouldn't expect the lighting to be such a big ratio of the total energy. So I was curious if Stuart could elaborate on that.
I think it was just something. I mean, it showed up in the modeling here, but it's also something that that we saw. You know, it was much higher than we predicted at Clayton Heights when we went back and did post-occupancy evaluation. And just, you know, we did see a lot of the lights on it, fairly deep planned spaces, you know, that the lights were on even in summertime on sort of bright sunny days. And so, you know, it's sort of, you know, we didn't get into the detail of that. We weren't the electrical engineers on that project, but it is something that just needs, daylighting, I think, needs more attention than perhaps we think about, right? It just sticks out when the heating and cooling loads are so small. The lighting is still relatively low, compared to conventional buildings, but it just sticks out in passive house buildings. I don't know whether, Sherman, you could pull up that slide that you had with the that showed the energy balance. I think it did show that lighting was quite high. But lighting controls and making sure people are turning them off is it's important, right?
Awesome, thanks. Yeah, daylighting is great stuff.
And Sherman, was the lighting just part of that plug loads? I'm looking back at that graph, and maybe if you do want to throw
No,
it back
I
up.
can share the screen again. Yeah, so yeah, definitely like common area lighting is definitely a good
Yeah.
portion of that. And plug loads is graphed separately here.
Right. Yeah, I was misreading the labels. Yeah, that surely visualizes it. Thanks for throwing that back up. Awesome. Well, I think we are finally ready. We're building up the momentum here to the question of, Sherman, what do you feel is the future of passive house and high performance building?
I think it's about sort of expanding what this certification standard could be applied to, right? So, I mean, first started with single family homes and then applied to multi-unit residential buildings. And then now we're starting to see applications to commercial buildings, so like office towers, fire halls, community centers. And I think that's where it kind of needs to go. And also sort of different construction techniques, right? Both prefabrications, it drives a lot of prefabrication, but also like kind of modular buildings. There's a unique set of challenges with modular buildings when it comes to applying PASO standard to them. Even though sort of on the surface, we think that modular building kind of lends itself to the PASO standard just because it's kind of like you're inherently limited to sort of like this boxy typographies. But definitely there's a unique set of challenges there.
For sure.
Thank you for trailblazing that. And just as we think that we have caught up with the chat, there's always something a little bit new. So it sounds like Dale N has a comment on water heating. Dale, do you want to unmute?
Yeah, I managed to unmute. Thank you. I thought Scott's comment was very pertinent. Looking up and being involved and looking into hot water heating lately for domestic use, all the manufacturers I see are really pushing tankless. So looking towards the future, I would think looking at non-tanked hot water, because that is really in the forefront of the manufacturers' websites promotions. And that is the way, with the low electrical cost you have in the Northwest, to reduce some of your energy loads, particularly in a community building where it's used at irregular times in scattered places. So I would think it'd be worthwhile just to evaluate it.
Thanks,
Yeah,
Dale.
I think I'll just jump in on that one. I think, for me, tankless hot water heaters work in, like, if you're in a distributed situation where you've got lots and lots of, long distances between fixtures. But when you actually look, like the amount of electrical heat you need to instantaneously heat water from 10 centigrade or 50 Fahrenheit up to usable temperature is in the 12 to 15 kilowatt range, right? And so what are you heating with instantaneously, right? Are you using electric heaters? And so if you're using electric heaters and you've got lots of simultaneous use, then you get massive electrical peak demands. And, we know that that's going to be a problem because there's, even though it's, especially if you get lots of simultaneous use of showers, so in residential situations. So personally, I think, storage, the way I look at storage, it's like a thermal battery, right? And it's a very cheap thermal battery. and you can trickle charge those things overnight. And so in a residential setting, where you've got like high peak demand in the morning, I actually believe that, storage with, low powered heat pumps, can, is a good answer. Yes, there's losses, but, a lot of the insulation that we see in domestic hot water systems has been historically very poor. So, I mean, so if you do a much better job of insulation of pipes and tanks, then those losses are somewhat lower. But I think we'll run out of electricity if we think we can instantaneously heat, water with electricity directly.
You're correct. However, it's just interesting to see the big manufacturers who make really good products going to all these on their websites right up in front. I've used tankless in Japan where it's natural gas. Here it's electric, and we still have low electrical costs in the Northwest and hopefully continue. There are just things to keep evaluating because for some reason they are changing what they're pushing in manufacturing, and they aren't there to lose money. So,
yeah, I would say if you're using natural gas, then you've got lots of power, and so you can do it, very cheaply with natural gas. But when you're doing, electrically, the unit itself is cheap, but the electrical demand on the building is not cheap, right? And the electrical demand on the grid is also not cheap. So, I don't necessarily think that that's the answer personally. I mean, yes, in some applications, but and the longevity of that equipment is not good either. We've used them in sort of big sort of manufacturing facilities sort of scattered around warehouses in the past, and they're quite sensitive to sort of dirty water supplies and stuff like that, and they foul up and fail. So the electrical ones, I'm not kind of sold on them, to be quite frank with you, but yeah, I'm not saying it's not a solution for some applications, but for large demand, like, multifamily residential and showers in community centers, personally, I don't think it's the right solution.
I feel like we should have a whole debate on this. Prescott's got some thoughts in the chat. Scott's got his hand up with some thoughts. I have some thoughts too, having installed one in a tiny house setting, and it really is, yeah, it's dependent on use. And I think in a setting where you have a lot of occupancy and you can have these huge demands at a time, they're probably not the right solution, but maybe in a, just a point source demand of like an office building where you just need to wash your hands sometimes, and and there's less occupancy, and you're not quite planning for showers and large uses. But it is an interesting point, Dale, to see kind of and follow what the market is doing, right? What is the industry telling us, and what are the products that are being pushed out, and why? Scott, final thought.
Well, one of the things that's interesting, we had a session with the city of Vancouver on embodied upfront carbon, as Lloyd Alter likes to call it. And one of the things that I find interesting is everybody's talking about the energy use at the building, whereas Passive House talks about the energy use at the source. And I think that's a huge issue when we're talking about embodied carbon. If we deal with it at the building, but you got to go build a dam, or you've got to go put in a massive battery bank for storage of energy or something like that. I think that's not captured very well in the way we think these days. And again, peak demand causes the need for peak and all of these kinds of things. So I think, in terms of hot water, I'm a big advocate for on-demand stuff in like where you're washing your hands or something like that, where you got a very small little unit that just gives you instant heat. In fact, I'm thinking of doing that I've got a little duplex I'm building for my boys right now, and we're thinking of doing that in addition to the standard. I'm putting a sand-in system in for the whole duplex, but anyways, it's that kind of thing. And I think we have to, I think that idea of that Passive House has, that we got to think about energy at the source, is missing in a lot of our conversations.
Here. Cool. Well, the future is debatable, but there's a lot of good movement, and Sherman, thanks for, as Zoe said, like paving the way with these building typologies, and showing us, and and helping all of us learn together.
Yeah, thank you, and thanks everyone for this great dialogue. Definitely an interesting conversation that we get to have here. So yeah, this is fantastic. Keep joining us, and we will see you at all the upcoming events. So see you soon.